Okay, can you see that now? Yep. Yep. Hello, I'm just going to check out that sound. There's a sound coming out here now. I'm just going to check out that sound. There's a sound coming out here now. Ah, okay. Seems to be better. Okay, I'll be with you in about 2 minutes. Just need to set up something, so apologies on the late start. Hello, and I'll turn on the sound even now. Apologies for that delay. A few technical issues here, and that Siobhan never seems to have when she's doing this. So, okay, so we'll just start with just to see this is our current stream, and we'll just start here with the introduction here. And this will, as you can see, I'm in the chair today and Siobhan is on Slack, so please send her any questions you have, and by all means I can answer any of them after breaks and stuff like that if needs be. Okay, so we'll have a look there. And so last week, when Siobhan was looking at classes and objects, she looked at properties, field variables and methods, and specifically the dot operator. So remember, a class is the template. So when you have an entity that's important enough to be kind of always on in a system, so it's something that's very important and that has presence and has, actions associated with and so on. And I suppose it's another day's work what we decide to have as a class, but a class is an important entity in a system. So once we have that template, we pack as much as we can into that class, into the code of the class, and then every object that is of that type gets all the good and the bad, I suppose, of that. So mainly we have properties, which we generally tend to call fields, and methods, which you can call as behaviours as well. So essentially, an entity generally is data that we work on. So we have the data stored, if you like, in the attributes or the fields, and the methods then that either looks at them, changes them, prints them out, whatever. Now you can have loads of different objects of the same type. So I keep saying, you could have a template of a car, and that would be on your wall, a picture of a car with all the different things on it. And then you have a car park, and there's loads and loads, there's hundreds or maybe thousands of cars, all from the same template. So one class, many objects, and the more you do on the template, the less work you have to do every time you create a new car, because the more information you have there, the more checks you have in it, the less you have to decide every time. So the first class that we created in this way is called a bank account, and we looked at the behaviours, and really, if you're talking about a bank account, what are the sort of details that you need? Well, really, the function of a bank account is that you can deposit money, withdraw money, and then you might want to be able to, towards the end of the month especially, display how much money you have and all this kind of stuff. Now, so we looked at that. So in order to be able to deposit money, you need to be able to hold what money you have, and that leads to the field. So never worry, you're never going to be designing a class by starting at line 1 and getting everything right. You're going to decide what it does and then what data you need and so on. Then we looked at the idea of the this keyword, which kind of helps us tidy up the constructors and the setters and so on. Okay, and today we are going to look at adding functionality to the bank account. And so, having the data, how are we going to actually do things that make the bank account useful and robust? Okay, and that's where we're starting today. Okay, so just while I'm, thank you. Okay, right. Just give me a moment there. So right, so the first thing we're going to look at, or the first thing we're going to look at is this idea of encapsulation, right? And the whole idea of having the class there is that we want to have everything in the one place. So like when you think of the template of the plan of the car on the wall, the more details you have on that, the more, plans of operation, how do you, test that the car is okay, the more you have there, the easier it will be to design the 1,000 cars, or to create the 1,000 cars. If you have a very rough sketch and you haven't put in or built in tests to make sure it's safe or like that, then every time afterwards you have to worry about, is it safe or whatever. So you do as much as you can in the template, and that will help you as well. All right, so I'm just standing up here now to make myself more active. So there you go. So we're going to look at that then, and the first thing is we're going to look at the last version of the bank account we had, right? And we'll have a look at it here. So here's our class diagram. What really are the basics we need? We need to know the name. And I remember Elon Musk, and God love him, he had very little money last week, so we're hoping he's made a few more dollars for himself. I did read something that mentioned $1 trillion, which is rather quite a lot, I think. So we have the name, an account number, which, as you know, is going to be towards a unique number. Now, things like this, just to mention to you as well, right? We know that there's things like unique identifying, primary keys and all that, and you'll be looking at that probably next semester. But for the moment, we don't do any coding to make sure they're unique. Okay, we'll do that later, but there's a lot going on, so we've enough going on. But at the moment, we'll say we have an account number because we expect to have an account number, and we also need to have a balance. And you can see here as well then that you can see that we have two constructors. One is what we call a default instructor. So that is no parameters. So generally what we use those for is if we're testing things, so that you can either pack a hard-coded value in or put everything in as a default, whatever way you want to do it. But the next one is kind of more usual one. And what that does is it generally has a parameter per field. So what we're going to do is we're going to say we have 3 fields, we can manage all of those, and we're going to do that via the parameters. Now the other things you need as well is we do need to be able to deposit, and when we're depositing, you can see here we're just going to deposit a number. Now we don't need to name what the variable is there, because the most important thing is that we say what the type is. And again, with your naming, if I see a method that says deposit and in brackets double, I know I'm going to deposit a number value. Even more important than a deposit, sadly, is the withdraw. And again, the withdraw double is quite important there. And again, you're going to know that you're going to withdraw double. Now that doesn't mean that you withdraw double the amount that you deposit. So my accountant tells me, don't always believe him, of course. So that's and the display then, it would be like what we will more generically call the toString later. Okay, so we're going to have a look at those, and you can see there that's an overloaded constructor, which means I have two names, but they're distinguishably different, and that's what we always want. They're distinguishably different because they have a different number of parameters. So you can have a different number or type of parameters. And okay, so here we have version 6. We have our 3 fields, and we have a very straightforward constructor. So that just says I have 3 fields, throw them all into that. The first bank account just creates that. So what happens if you just have nothing in it? You do create the object, but the object, all of the fields default to default. So for instance, in this, the name, because it's a string, would be null, the account number double would be 0.0, and so would the balance. So and that is okay if you follow it up by giving it values, but this is a lot more useful, the second one. Right, and here's our code for deposit and lodgement. Now, so you can see here, we're going to look at the code here, and you can see that the deposit here, we have our balance over here, and all we're going to do is we take in the lodgement, and we add it to balance. That's what happens when you have a balance. When you have a lodgement. Now we'll come back to that and see is there any way we could improve that, but we'll see that later. The next one is, if I want to withdraw, and this is the sad bit, right? You have a balance, and if your balance just says 1,000, but you need to take out 2,000, whoops, we're in bad luck there, because the withdrawal amount is not less than or equal to balance. In other words, you can only take out what you have, and it's going to tell you, sorry about that now, but you can't do that. All right. And if that is the case, you're going to say unable to withdraw that due to insufficient funds. All right. And okay, so up here you might say, if you think about, is there any, for deposit, is there any rules you want to make about the lodgement value? And an obvious one would be there to say that it should never be, at least it should never be negative. Maybe it should be positive as well, because there's no point in lodging zero amount. Okay, and the display down here is, we will be calling these toString later. It prints out a string, sorry, it doesn't print out, excuse me, it generates a string that gives you a description of the field values at the moment. Okay. So this one is, in the very first one, if we just remember, we just hard coded because we were being very bold about encapsulation, and as we move forward, what we're going to realize is that this is just looking for trouble. So in this account number here, I have no way, when I'm putting values in there, I have no way of doing any kind of validation on it. And you can see there that I could have put minus 1,500 there, and that would just allow it to go in. Okay, so what we're trying to get to is the fact that, like I always say, you know, if I'm putting in a value for the balance there, that I happen to have a balance, if I put in 20 instead of 21, there's nothing I can do as validation there. That might be an incorrect value. But if I put in minus 1,500 as an opening balance on a deposit account, that's invalid. That can't happen. Yep. Okay, so there's two differences. So what we're trying to aim for is that we can guard against invalid values. There's not a lot we can do about people that type incorrectly. Okay, so that's our value where and why can we do this? We can do this because all of these, because they're not mentioned, all of these over here are actually private, or public, excuse me. So we can directly access them, which is, we call that our design smells. Okay, so we don't want that to happen. And so we want to set it to a value. We could set it to a value that's completely preposterous. And as I said, we can only make sure that values are valid, but at least it cuts down a lot of deliberate or unintended consequences. So we're trying to, if you think about it, if we're trying to access a field or change the field or whatever, that is a behaviour on the field. We're changing it, we're printing it, we're returning it, we're doing whatever. Methods are supposed to, we're supposed to ring fence the method to do anything like that, anything that's an action. So this is where encapsulation comes in. So remember what encapsulation is in general in English. What you're doing is you're bringing you're bringing everything together. So in this case, you're going to be bringing in fields, methods, which include the constructor. Constructor or number of them. Now remember, I think I did mention to you as well before the idea of the music system. And do you remember that? There was the amplifier. There was the CD player. Then the, I'll call it the record player. And the idea here is that everything about the CD is there. Everything about the amplifier is here, and everything about the record is here. So I can either have a really good CD player or really poor, but it's actually going to, the user manual of it is going to be the same. Okay? Now the user manual could be different, but you could actually update the insides of the CD player and make no change to the interface, and that's what we're going to be looking at. But anyway, the fields, methods and constructor, what we're saying is, we call this very high cohesion. Everything about the CD is here, and everything about what we're now going to look at as bank account is here. So any validation that needs to be done for any bank account, we're going to do here. Any data we need to have for any bank account, we're going to do here. Any behaviours like deposit and thing, we're going to manage all that here. If there's something you need to do every time you're accessing a bank account in the driver or in the manager in another class, if there's something you need to do every time you access it, then look at how that maybe should be in the class. So do as much as you can in class. Remember the car plan on your wall. Do as much as you can, and then you've less to do every time. Okay. So what do we mean by encapsulation in programming? So the whole idea of data hiding is very fundamental, and basically you know as much as you need to know about anything. Okay, so when you're playing a CD player, you only need to know what the buttons do. You don't need to know how they work. Now, why is that important? And data hiding is the same, right? You need to protect, and in a way, by doing that, you're protecting, in the CD player, how the reader is working, because nobody can touch that. The only thing you can touch is whether it's play or whatever. So how do we achieve the encapsulation? How do we make sure that there's enough in in our case, the definition of bank account, so that everything we need is there for any time we are creating a bank account. So the first thing is that we wrap the fields and the code. And remember, I said as well, you're not going to start in line 1 and know what all the fields are and then know what all the methods are. You'll think of what happens at each point. You'll think of what happened at each point, and then you say, oh, but in order to be able to deposit, I actually need to know, I need to know the balance because I need to change that, so I'll definitely need that. I need to know maybe the account, because if I have loads of bank accounts, I need to know which one to put it in, and so on. We need to hide the fields from other classes, because I want to manage what goes into fields as much as possible. And that's very simply done by simply making them private. And our rule of thumb is that all fields are private. That's it. All fields are private. So if they're private, nobody can access them. So we can only access them through the methods of their current class. Okay? We'll see this. So this is just a kind of a recap of it. So we wrap the data and code acting on the data methods as a single unit. So inside, even though we don't, head them, we don't have a header that says this is the way it's going, but we have the fields first, and then usually we have the constructors. Now you don't have to have them in this order for the compiler to make sense of it, but please do. Okay, please do, because it's just much nicer and it's easier to keep it read and so on. Okay. And then we have our methods. So we have fields, constructors, and then the methods. Okay. Declare all the fields as private. And what we're going to have is public setter and getter. Now what we're going to say is, by default, right, have all of your methods public. And then later we might see how some of them actually they'd manage as... you manage as the private. Private can be better in some cases. Okay. So now we're going to try and make our bank account a little bit better, and we're going to start implementing, and hopefully you'll see two things. You'll see how to do it, but you'll also see what the benefit is on it. So the first thing is the access modifiers. So very simply, we'll look at what we mean by the access modifiers. And there's 4 access modifiers. Visible to the package, no modifiers needed. And if you don't put anything in, that's what comes up. To the class only is private. To the world is public. And protected is, you can think of it as in between. When we look at inheritance, we'll see this. We're not going to worry about it. We'll just concentrate on private and public. So it's either available to everyone or available just to the class. So we have a file name or a class called bank account. They happen to be the same thing, but we call it a single unit. And here we have our fields that are fairly so we need to just start. Whoops, did I get that? Yeah, we need to start by looking at this and seeing here and saying, oh, that's a bit minimal really, isn't it? And so we need to look at that. So we've just started by calling this public class bank account. So other classes can actually access it or create something of this type. And then for this one, we don't want this. This is what we do not want. So what we're going to do is we're going to change that and put private in front of every single field. So that means that, what does that mean? That means that if I have a bank account called, I'll call it B. Whoops. If I have a bank account called B. I cannot say B name is equal to something that's 100 characters long. All right, I can't do that. So I'm going to have to come up with another way to do it. But guess what? We have stuff already that'll do that. Okay, so we need to look at how we're going to do that. So you can see a constructor here called deposit. All right, that actually does change the value of balance. Okay, and methods can do that because the method, remember, is in the class, so it can access all the fields, so it can do what it likes with it. Okay, so what are we trying to do here? We're trying to get a mix of, I want to have full control over who accesses my data. In other words, I want to be able to put in rules that says that's valid, that's okay, or that's not valid, that's not okay. Okay, so if we look at the name and so on, we can think of the analogy of if I had a garden, right? Now, if I have a garden and I leave it completely open, that's kind of like what I had the fields in. But if you have a garden and you've lovely flowers and so on, and you leave it completely open, there's a chance that people might come in and chop the heads off all the flowers or take them home, pretend they've bought them, and get all the credit for that, and all of these things, right? So instead, what we do is we say we're going to guard. So I always think of this as like you're putting a fence around your fields, okay? And you're saying to get in here, really, you're only going to be able to get in here through here, okay? And you see, we can write the code for that then and just be saying, you know, we can decide exactly when you can deposit. So you can deposit, it's not just a matter of adding something to balance. If you're depositing, it must be positive or non-negative, whichever. Okay, so we're going to look at the access. So when we have the fence here, I have a fence here, and you can see why I do, because I don't want people taking home all the flowers. But I do want them to be able to see them. And I do want some people to be able to go in and water them or give them food or weed them or whatever. So I need a bit of both. So here's where my mutators come in. Anytime I want to make any changes to the garden or the bank account, I need to do it via a method. Okay, so in here, if I want the getter, the idea of the getter is like allowing people to look in over the fence. All right, they can just take a picture of the data. So it's a returning of what's in there, and you can have we will have a getter for everything. So you can, an outside class has access to the current value of any of the fields. The setter then, an outside class, can access, so they can water the plants, or they can, you know, but if they bring in, so the idea would be, if you're watering the plants, before you water the plants, the guard is going to check, is it poison or is it water? Okay, so before any changes are made to the fields, you're going to check what's in the data. Okay, so here we say we have all our fields as private property, and if an outside requester, they can get to here via the methods, but all the data will be checked before you make any changes, if you code that in the way it is. All right, so you have the benefit of the two things. Now the downside is that you might say, well, I only want to, you know, access the values and I still need to do a getter. Well, you can't have both. You know, you can't have I'm only going to change it, you know, so you have to make them private, and then you can access them by just having a getter for everything. Okay. So the getter then is a method that simply returns the current value of a field or an attribute. So this is what it looks like. If my field name was X, it would be get X, and it would be return X down here. So get balance, and you use your camel case as well. It's going to, here, remember what this does? This promises, here, this says, I promise you when I return something, it's going to return double. And then here, it says, and actually the double I'm sending you back is the value of balance. And the return type must meet there. So remember, in methods, you're getting information, if there's information there, via your parameters. There's none here. And you get the information back out via the return statement, if that's there. There's other ways of getting information out, you know, usually by fields, but for the moment. Okay, so once you get the idea of what the getters do, it should be easy to write getters for every class. Okay, the parameter list is empty because you don't need anything else. You know that if it's get balance, it's the get balance field. And that's, remember, when you're writing an if statement or something like that, if there's only one statement, you can ignore or not use curly brackets. But in a method, you must use the curly brackets even if there's only one statement. That's the return type. It's the promise, and that's the actual value that goes back through that channel. And remember, in return, it doesn't stand out here, but remember, when a return is executed, two things happen. The value goes back, but also there's immediate termination of the method as well. Okay, the setter then is the one that we need to be careful about. So if you're only reading data, even if you print it out in the incorrect form, you're not changing data, and we need to be really careful about data. We need to say, at best, at all stages, I need to make sure that there's only valid data in there, so there's no minuses in there if it's a deposit account, you know, and so on. So a mutator method, mutate, remember, means change, and a particular kind of mutator method is a setter. And basically what that does typically is it takes in a parameter, it uses an assignment statement to change the value of the field based on that parameter. Now the key there is, as we get more sophisticated, that what we're going to do when we take in the parameter, before we change the object state, we're going to do checks. We're going to check, are those values valid? All right. So before we do it, and if they're valid, we'll use the assignment statement. So this is a simple setter. So in this case, we have divisibility. All methods will be private just for the moment. Return type is void because what I'm doing is I'm changing the value of a field. Now I'm not making any decisions based on it. I just do that always. Set balance, and I have the double balance there. So you can see here, and remember the use of the this. So this is my local variable, and here, and this is my field value. Okay, so any logic that you want to do, checking about valid, is going to be based on the input that you're trying to do this with. So if you have any if statements, it's going to be based on the blue. Okay. So we have our method name, and in the same way as we said get X, if the field is X, it's get X. Here, if the field name is X, it's set X. And if you use this structure where you're using this dot, it makes it much cleaner, because whatever the name of the field is, if it's a good field name, it's a good parameter name. So you can just, this is kind of the way we're going to do that. So this is our parameter. And remember, when we write or declare a parameter like that, what we're actually doing is declaring the local variable balance for the scope of this method, which is basically down to here. And by saying this balance, what we're saying is take this value here that comes from the outside and put it into the field version of balance. That's field being mutated, and that's the assignment statement, and that's the value passed in directly. So here we have our fields here, all nicely privatized, so to speak. You can see the name is in red, the account number is in green, and you can see here that our getters look very similar, and they always will actually, they always will. So you can see here the blue, balance is a double, so you're going to return a double because the balance is double, and then you're going to return the name of the field, and so on. Okay, so the getters, there's very little logic in them, it's just throw me back the value. Don't change it, don't do anything, just throw it back. So these are the different ones. So if it was X, it would be get X. The setters, on the other hand, at the moment they're very straightforward, they're very vanilla. We just say set the name, take the value in here, and update the field value. Set account number and set balance. Okay, so for each instance field, you're normally asked to, sometimes it doesn't make logical sense, like if there was a kind of a system value that needed to be changed internally, but for the moment we're going to ask you to write a getter and setter for every field. Okay, now do you remember before the refactoring we had all these Richie Rich and account number and balance, and luckily enough nobody was either deliberately or accidentally putting in really bad values. Okay, so we'll see how we would change this. So here we set up the so we were using our constructor, but in the next one what we do is we use the constructor to set all these values, and then for this and the balance is, and for this we're going to write a deposit method. And within that deposit method, you see, I can check, have I enough money? I could do that here, but every time I'd be doing a withdrawal, I'd have to check it separately. Whereas the idea is, if I have it in the bank account class, it's automatically done every time I have. So I'm trying to generalize as much, to put as much in the bank account logic as possible. So here we have, I could have either done the constructor or just used the setters. So I'm going to say set the name Richie Rich, that's our red over here. Set account number. Now we're not getting any extra at the moment because we haven't put in any validation, but we will, and now we have the capacity to put in the validation there. We haven't done it yet, but we can do it. Honestly, we can. Okay, so set the balance to 1500, and so we're happy enough that our fields and methods are in a single unit. The fields are private, the methods are public, and we've done that. But we now want to be able to see, now we start getting the payback for having the setters and the getters and hiding. And remember, if the guard is at the gate and you say your job is to water the plants, if the guard checks, is it water, is it good water rather than poison or bad water or whatever, then they can let you in. So now we have, because you have the guard at the gate, the guard can do this checking, and you can see the setters or other ones as like these guards. Okay, so we're going to look at this and now we're going to start getting the benefit of the structure. This is our current constructor, no validation. So there's very little functional difference between this and just throwing the values into the fields. Okay, but now what we can do is we're going to put some validation in, not all, we'll get back to it all. And we're going to see here, right, that we have our balance. Right, now this is a deposit account. All right, so we can only start, it makes sense that we can only start the bank account with a balance of 0 or more. So if the balance is coming in via here, because remember that's field value, great, everybody's happy, and we put that value into balance. Otherwise, what we do is we say we put in a default value of this dot balance, and we put, of 0 into this dot balance. Okay, because if we put in that is a minus value, or that we're saying we're starting with an overdraft, which apparently is not great, that you actually will at least put a valid value there, because if it's you know what I mean by a deposit account, you know, the ones where you don't have an overdraft or so on, that makes sense. So now we're kind of happier with the way this is done. All right, we're happier, not fully happy, but we're happier, because we're kind of saying, well, at least no bad things will come in there. So this is what we call the default value. So it's not brilliant that you've only 0 money in your account, but at least it's not negative, which you're absolutely not allowed. Okay. Now in the set balance, right, now there's 2 really important things here, right? You'll see that the logic of in the constructor, this is very similar to the, this is very similar to the setter code, but we have an else here. Okay, we have an else here. What we're going to look at is trying to make that kind of cleaner. Now in the setter, remember this, we talk about this, I think there is no else in setters. And the idea there is, because what we're saying is, what we're all about is having only valid, like basically if you've written your code properly, at every stage you will only have valid data in your object. Okay, it may not be correct because somebody could put in 20 instead of 21, but at least you're not going to have a minus balance if that's not allowed by the laws of that. So in the setter, what we always say is, if the value we're trying to change it to is a good valid value, we'll allow the change. If it's not, we do nothing. So we don't allow the change, we don't make any changes, so that you know, it's not updated, but at least it's not invalid. So we never have an else in a setter. In some cases, in some programming styles, we do, but not for us at the moment. We're just going to leave that. Okay. So the validation is done at constructor level, must be repeated. So if something isn't right to go in at the start, it's not going to be right when you're changing. So the logic is going to be the very same. Now, anytime we have a repetition of data, we need to kind of look at that as well. Okay. There's no else. Remember that. No else, no else. Okay. So, in this case, we access the fields only through the guard at the gate, only through the getters and the setters, and maybe other mutators as well. We make the class public, fields private, and at the moment we only look at the private and the public access modifiers. Okay, so our accessors at the moment are get, the mutators are set, and we generally write getters and setters for each field. So the kind of validations we look at would be to test is a value between max and min. So for instance, we might say if we want to do a deposit, you can only deposit between 0 and we'll just say 5,000. I've never checked that one out, but just say that there's maximum values you can actually start, and in the constructor you can apply a default if it says, and then in the setter you can ignore the update if the value fails. Okay, and then in the encapsulation you want to have everything, as much logic and data as you can in the class, so that when any object is there it's ready to go. You hide the fields, private fields, and you make all the methods at the moment public. Later on we'll see that some of them will be private. For the moment, default them to public. And we can apply validation in constructors and setters, and anytime we're changing anything we can always make sure that we're not going to invalidate data. Okay, so what I'm going to do is I'm going to take about 7 or 8 minutes, and I will come back to you then. All right, and then we've more to do on bank account. Okay, thanks a million. And I'll put on the timer. Okay. So, hello, we're back again, and we are now going to do a little bit more on the bank account. So there's not that much more, so hopefully we'll finish up 1 week at least, maybe even on time, perhaps, maybe more. Of course, that's the kiss of death, isn't it? All right. So, okay, so we have a waving person there saying, hi, the bank project is looking good, but I forgot to tell you that, we've an overdraft limit. That's actually a very sad story about having an overdraft limit, I find. When they're set up, we determine if an overdraft is allowed, and if it is, we add a limit. And of course, you can withdraw up to this. So can you fix that and get back to me? Because it seems to be working, but not really applying our policies. And of course, because the programmer is always right, no problem at all, and then goes away and cries. Okay, so, and then sometimes the deposits are free, sometimes they're paid. There's a fee to be paid in them. Can you include that as well? Given up at that point. Okay, so what do we need to change? So and this is why, you don't have enough fields there at the moment to be able to allow you to do that. So think of what you need to do. You need to check, have you enough money to do things? Now, you can almost think of, if you like, zero at this point as being hard-coded. That it's a limit, or it's our natural limit. But if you're implementing an overdraft, then you need a separate thing that says limit. Now, if we want to a field, it could be an integer or double. We didn't get any details on that, so we can either go back and ask the bank manager, or stay safe and go with the double, because everything else is in double. So it would make more sense. And remember, even though you should always, and this is a kind of a general design point, if something is definitely an integer, you should always do that. That, for instance, is in for loops and all those, right? So keep it an integer when possible, but if there's any system reason to go with double or float, stay with that. So if we have that, so we're going to need a field. We're going to need to be able to set up an account. So generally, if you're setting up an account, they'll say to you, do you want an overdraft? Or normally you say to them, can I have an overdraft, please? So in construction, you need to be able to take that into account. So the first thing we need to do is to update the existing constructor to update the limit. We need the new field, and we tend to, as much as possible, to have a getter and setter at each time. And then the withdraw method is going to take the overdraft limit into account, because now it's not, as you can think of it, the limit was hard-coded to 0 previously. Now, if there's a fee, if one applies, you need a separate, because if you think about it, unless you have a kind of a percentage thing that you can calculate within the deposit, you need a separate one that actually has a fee. So our main class, we can just ask, is there an overdraft? And if it is, what's the limit? Otherwise, essentially, the limit is 0. We call the new constructor and pass it the limit. We deposit money with the fee attached. We need to have that. So the new field here is limit. We left it at the double because we weren't going to take any big chances, and there was no need to leave it as an int. It didn't make any systemic sense to do that. So here's a constructor now. And at the moment, we're not doing any checks on things. So we now have a second constructor, because we already have the constructor that has string name and account number and balance. And now we have a second one that has limit as well. And remember the overloading idea. If you have one method with 3 and another method with 4, the calling method will automatically land on the one that's suitable. So we don't have any validation on this. We have our validation on account number, on balance, my bad. And the limit, then we're just pulling in the limit. Okay. So in the existing constructor, which we're going to call if there's no limit, we can now be clever about just having the limit as 0 when there's no deposit, rather than having a special case when there was an overdraft facility on it. So instead of having one set of methods for the non-overdraft one, we just simply set the limit to 0. So we've get limit, and we're not doing any validation there, so that's get and set. Now for the withdraw, we do have a difference, something to change here. So before we said, have we enough? But the balance plus the limit. So we have our balance, and just say our limit. Now, so when we say the limit is 1,000, we actually mean that we can go to minus 1,000. So the limit here is, if the withdrawal is balance plus the limit. So just say in the previous, just say I have 500 and I want to take out in my account, and I want to take out 800. 800 is less than 1,500, so I'll be allowed to do that. Now it means I'll have minus 300 at the end, but sure, things happen. Okay, and so in that case, I just update the balance. And now in this case, I send back a string that says withdrawal successful. Now, I know some of you are asking questions, and they're really good questions, about when we have a setter, right? We say void. And you could say the withdraw is, it is a mutator because it's changing things. So I just say here, I have the if x is greater than 0, we'll just say this dot x is equal to x, and there's no else. Okay. And people are saying, why is it void, right? And the answer, it's a really good question, right? Because we could use this, and we could use that as Boolean. And we could say here, return true, else return false. God, my writing is terrible. False. Okay. We could do that, and that would allow us to send information out from the driver, but we just don't do that at the moment. We just leave it simple, that in the setter we just either change the value of the field or not, and we give no information about that. So it's a really good question, but we're just going to leave it like that. So in withdraw, we're actually returning the string. So that if that was Boolean, you return false if it was unsuccessful, and true otherwise. Yeah. So, but good questions there. Keep them coming. The deposit. So we have a fee here. So we're going to have 2 deposits. This is the first one was withdrawal, but the first one here is when we have a fee, and the balance is changed by adding lodgement minus fee to that. Okay, it's a new one. So now you could do a number of things here. You know, there's a lot of validation just say that you could do. So for instance, it might be reasonable to say that the fee can't be more than the lodgement, because you couldn't be sure, and all that. So you can bolster up all those things. But now, right, we have a few reasonably robust and some not methods. So when we're in the main or the driver program, we now see that okay, an awful lot in the driver, because this is where we manage everything, all the I/O. We're going to say we set up a bank account, then basically we get values, we read in values for all the fields. Okay, so now we have 3 fields: name, account number, balance, which were original fields. And now we're going to say, does the account have, do you want an overdraft? And apparently some people say no, God bless them. So you can see here, I'm going to, so this is all about deciding, oops, this here is all about deciding which of the constructors you want to set up. Okay, so if you have an overdraft limit, you tell the system what it's going to be, and you set it up with a limit here. Okay, so if you type in 5,000 there, it's going to be 5,000 there. Yeah, so you're going to set up that limit. Now remember, in this constructor, you don't need to set it up, but it automatically makes limit equal to 0. All right, so you could have actually just called that one, you could have called that one there, you could have called it on 0 limit, but we leave it at the other one. All right, now the thing about the driver, and this is the driver thing, the driver code. Remember what we said about the driver, right? All input and output come in through the driver, and when we're looking at a general system, there's going to be get the input, in whatever way that is. The next thing you do is you process it in some way. Now this is a very simple breakdown, and then you output or put in some values. Now you can have outputs in the middle of things and all that, but in general, all right, that's the kind of linear thing. And inside in the process you can have different things as well. But remember, you'll need to be getting information out. And what we say is, do not have a println or an input scanner in any other class other than the driver. Why do you do that? You do that because then you might say a year down the line you want to change it, and you want to change it to use a nice UI. Okay, so nice UI, user interface. So you might have, nicer way of putting in the input, nicer way of getting out the output, and so on. And all of that, I/O in a way, is in the driver. So you only have to change the driver. So basically, you can't see behind me, but there's, building blocks. So it's like when somebody talks about a building block, and luckily enough, in fact, we have it on, why not? So, because technical problems today, I didn't get. Okay, that's gone all the way up. You can see here, this is one building block here, right? There's another building block, there's another building block. Once those building blocks are built, we use them in different ways, all right? So the person that designed that said, I don't know what the house is going to look like. I don't know how the office is going to look like. All I know is I'm making these available to you. And you can think of that as, your bank account or whatever, or, as we move on, different classes. How you're going to use them is different. But to make them more reusable than before, if you like, everything you do, so anytime you're returning a value, or you're trying to have something that will print out the deposit or whatever, you don't print it out at this level, okay, because you don't know where. It's like as if that could only be used in a particular kind of a greenhouse if they were all painted green. So you present back the data so that the driver can decide what they're going to do with it, in the same way as we can decide whether to build an office with it or paint them green and have it as a house, and so on. Okay. So, with the fee attached then, you would expect that how much money do you want to deposit? And you're going to type in, you're going to type in your double. So, this is on the driver again. So, you have a deposit amount, and if the fee amount is next double, you're going to say if the fee amount is greater than 0, then that's what you're going to do there. All right. And the bank account then is the deposit amount. So you're either going to have a fee or not. So you're saying you can't have a negative fee because that would be bold. And remember again, you could have put that, if that's a reasonable thing to do, you could have actually put that in the bank account deposit, so it was always there and you wouldn't have to check that. Now, I mean, you kind of, you might say for 0, and you could actually put that as 0 and call it again. So there's a few different ways of doing it, but as much validation as you can in that. Right. And that is it. So we are finished a bit early. I'll just check with Siobhan, is there anything you need me to cover? Or actually, I'll put on my Slack there. If there's anything you'd like me to cover now, just shout, so to speak. Virtually shout, and I can do that. We're all good. Nobody wants to do anything? Great. I don't mean great, I mean this we're here for. But I'm glad if you seem to be on top of things, and that Siobhan has been keeping you happy. Okay. So yeah, I can't see that, but I blame Siobhan if I got the wrong information. So listen, thanks a million, and we are thanks a million again for submitting the code. We will be getting onto that this week. As you can imagine, it's quite a bit to do, but we are on it, and we're not forgetting about it, so don't worry about that. Okay. Right, so all is good, and yeah, we might have a quick look at the thing again. So have a look at the lab then as well, and you can see there there's a lot of usually, as you know, in the labs we go through what we've done, and just to have a look at that and to buy into it. Okay, so I suppose just to let you know that this year we've done a lot more kind of asking questions in our daytime class, asking questions during tutorials and getting students to write things down. And we found that the students are learning an awful lot more because they're more aware of what they don't know. So just be, and I'm not, you know, if you're struggling at it, don't worry, you're kind of aware, but don't take the comfortable option of sitting back and watching us code, and, you know, because you've IntelliJ and it might be helping you out doing things. So please try, and if you can, try write things down on paper to make sure you understand the runnings of it, because it's really tempting to write something in and see does it work rather than be sure it does before you write it in. And I suppose that's one of the big changes that we've seen this year when we actually have taken that approach. So just if you can help yourself by doing that, that would be great. And of course we're available in labs and so on this evening and Wednesday evening as well. All right, so we will continue on in the encapsulation on Wednesday, and I'm sure you can't wait for that already. And yes, but I will see you then and talk to you then. And thanks a million to Siobhan for sorting out my technical issues at the start and also for answering your questions. Okay, so thanks a million and talk to you on Wednesday.